Article 517.16 of the National Electrical Code states that emergency circuit wiring shall be installed in accordance with the requirements of Article 700, except as modified by this article. Wiring methods shall be Type MC cable, Type MI cable, Type AC cable, electrical metallic tubing, rigid metal conduit, intermediate metal conduit, surface metal raceways or other approved cable or raceway. Standard MC cable, also known as Romex, is not included in the list of acceptable cable types for emergency lighting circuits. Since the installation is not compliant with Article 517, it is necessary to find a solution to bring it into compliance. There are several options available to address this situation. Firstly, the existing MC cable can be replaced with an approved cable type. This involves removing the non-compliant MC cable and installing a cable type that is permitted under Article 517.16a. Examples of approved cable types include Type MI cable, Type AC cable, electrical metallic tubing, rigid metal conduit, intermediate metal conduit, and surface metal raceways. Secondly, the possibility of installing Type MC cable with the appropriate fire resistance rating, known as a FR-MC cable, or another approved cable type such as Type MI or Type AC, exists. This option involves using MC cable that is specifically designed to withstand fire for a certain period of time, providing an added layer of protection for emergency circuits. Thirdly, another solution involves enclosing the existing MC cable in a fire-rated raceway. This can be achieved by installing the MC cable inside a conduit or raceway that has a fire resistance rating. The raceway acts as a protective barrier, preventing the spread of fire to or from the emergency circuits. Fourthly, the existing MC cable can be installed in a fire-rated raceway or conduit that provides the necessary level of protection. This option is similar to the previous one, but it emphasizes the importance of ensuring that the chosen raceway or conduit has the appropriate fire resistance rating to meet the code requirements. Fifthly, the possibility of installing a fire-rated barrier between the emergency circuits and the rest of the building exists. This involves creating a physical barrier that prevents the spread of fire from the emergency circuits to other areas of the building, or vice versa. The barrier should be constructed of fire-resistant materials and should be properly sealed to prevent the passage of smoke and flames. It is crucial to ensure code compliance for safety and insurance purposes. Any deviations from the code could have serious consequences, including fines, penalties, and potential liability in the event of a fire or other emergency. It is also recommended to use hospital-grade outlets for healthcare facilities. These outlets provide additional safety features and durability, making them ideal for use in environments where patient safety is paramount. It is highly recommended to hire a qualified electrician for the installation and inspection of emergency lighting circuits. A qualified electrician has the knowledge, skills, and experience necessary to ensure that the installation is done correctly and in accordance with all applicable codes and regulations. They can also identify potential problems and recommend solutions to ensure the safety and reliability of the emergency lighting system. When selecting a fire-rated raceway, consider the required fire resistance rating. The fire resistance rating is the amount of time that the raceway can withstand exposure to fire without failing. The required fire resistance rating will depend on the specific application and the local building codes. Ensure that the fire-rated raceway is properly installed. Proper installation is essential to ensure that the raceway provides the necessary level of protection. The raceway should be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. When installing a fire-rated barrier, consider the location of the barrier. The barrier should be located in a way that effectively prevents the spread of fire from the emergency circuits to other areas of the building, or vice versa. Ensure that the fire-rated barrier is properly sealed. Proper sealing is essential to prevent the passage of smoke and flames through the barrier. The barrier should be sealed with a fire-resistant sealant that is specifically designed for use in fire-rated assemblies. When using hospital-grade outlets, ensure that they are properly grounded. Proper grounding is essential to prevent electrical shock. The outlet should be grounded in accordance with the National Electrical Code and all applicable local codes and regulations. It is important to regularly inspect and maintain emergency lighting circuits. Regular inspection and maintenance can help to identify potential problems and ensure that the system is functioning properly. The inspection should include checking the wiring, connections, and outlets for any signs of damage or wear. It is important to test the emergency lighting system regularly. Regular testing can help to ensure that the system will function properly in the event of a power outage. The testing should include simulating a power outage and verifying that the emergency lights turn on and provide adequate illumination. It is important to keep accurate records of all inspections, maintenance, and testing. Accurate records can help to track the performance of the system and identify any potential problems. The records should include the date of the inspection, maintenance, or testing, the results of the inspection or test, and any corrective actions that were taken. It is important to comply with all applicable codes and regulations. Compliance with codes and regulations is essential to ensure the safety and reliability of the emergency lighting system. The codes and regulations may vary depending on the location and the type of facility. It is important to consult with a qualified electrician or building inspector to ensure that the system is compliant with all applicable requirements. In summary, when dealing with non-compliant MC cable in emergency circuits, several solutions exist. These include replacing the cable with an approved type, using fire-rated NEC cable, enclosing the cable in a fire-rated raceway, or installing a fire-rated barrier. Always prioritize code compliance. Use hospital-grade outlets where appropriate, and engage a qualified electrician for installation and inspection. Regular inspection, maintenance, and testing are crucial for ensuring the ongoing safety and reliability of the emergency lighting system. Furthermore, specific considerations for each solution should be taken into account. When replacing the NEC cable, carefully select an approved cable type that meets the specific requirements of the application, considering factors such as voltage rating, ampacity, and environmental conditions. When using fire-rated NEC cable, ensure that it has the appropriate fire resistance rating for the application as specified by the local building codes. When enclosing the cable in a fire-rated raceway, select a raceway that is listed and labeled for fire resistance and install it according to the manufacturer's instructions. When installing a fire-rated barrier, ensure that it is constructed of approved materials and that it is properly sealed to prevent the passage of smoke and flames. In addition to these specific considerations, there are also some general considerations that apply to all of the solutions. Ensure that all electrical work is performed by a qualified electrician who is familiar with the National Electrical Code and all applicable local codes and regulations. Obtain all necessary permits before beginning any electrical work. Carefully inspect all materials and equipment before installation to ensure that they are in good condition and that they meet the requirements of the application. Follow all safety precautions when working with electricity, including wearing appropriate personal protective equipment and energizing circuits before working on them. Thoroughly test the emergency lighting system after installation to ensure that it is functioning properly. Provide adequate training to building occupants on how to use the emergency lighting system in the event of a power outage. By carefully considering these factors and following these guidelines, one can ensure that the emergency lighting system is safe, reliable, and compliant with all applicable codes and regulations. The use of hospital-grade receptacles is highly encouraged in patient care areas. These receptacles are designed to provide a more reliable electrical connection and to reduce the risk of electrical shock. They are also typically more durable than standard receptacles, which can be important in a healthcare setting where equipment is frequently plugged in and unplugged. Article 517 of the National Electrical Code provides specific requirements for electrical wiring in healthcare facilities. These requirements are designed to protect patients, staff, and visitors from electrical hazards. It is important to be familiar with these requirements when installing or maintaining electrical systems in healthcare facilities. The authority having jurisdiction, or OJ, is the organization that is responsible for enforcing the electrical code. The AHJ may be a local, state, or federal agency. It is important to work with the AHA to ensure that all electrical work is compliant with the applicable codes and regulations. Regular inspections of electrical systems in healthcare facilities are essential to ensure that they are safe and reliable. Inspection should be performed by a qualified electrician who is familiar with the National Electrical Code and all applicable local codes and regulations. Any deficiencies that are identified during an inspection should be corrected promptly. Emergency lighting systems are an important part of the overall safety plan for any healthcare facility. These systems provide illumination in the event of a power outage, allowing patients, staff, and visitors to safely evacuate the building. It is important to ensure that emergency lighting systems are properly designed, installed, and maintained. When selecting components for an emergency lighting system, it is important to choose products that are listed and labeled by a nationally recognized testing laboratory, such as Underwriters Laboratories or Intertek. These products have been tested to meet certain safety standards and are more likely to perform reliably in the event of a power outage. The battery backup system is a critical component of an emergency lighting system. The battery backup system must be capable of providing power to the emergency lights for a minimum of 90 minutes, as required by the National Electrical Code. It is important to regularly test the battery backup system to ensure that it is functioning properly. The automatic transfer switch, or ATS, is another important component of an emergency lighting system. The ATS automatically switches the emergency lights to the battery backup system in the event of a power outage. It is important to regularly test the ATS to ensure that it is functioning properly. The emergency lights themselves should be located in strategic locations throughout the building, such as exits, hallways, and stairwells. The light should be bright enough to provide adequate illumination for evacuation purposes. It is important to regularly inspect the emergency lights to ensure that they are clean and in good working order. Building occupants should be trained on how to use the emergency lighting system in the event of a power outage. This training should include information on the location of the emergency lights, how to activate the system, and how to safely evacuate the building. In addition to the requirements of Article 517 of the National Electrical Code, there may be other applicable codes and regulations that must be followed when installing or maintaining electrical systems in healthcare facilities. These may include state and local building codes, fire codes, and accessibility codes. It is important to be familiar with all applicable codes and regulations before beginning any electrical work. Working with electricity can be dangerous. It is important to take all necessary safety precautions to prevent electrical shock and other injuries. Always de-energize circuits before working on them, and wear appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not qualified to perform electrical work, hire a qualified electrician. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Attempting to perform electrical work without the proper qualifications can be dangerous and can lead to serious injuries. In conclusion, ensuring compliance with Article 517 of the National Electrical Code is crucial for maintaining electrical safety in healthcare facilities. By following the recommendations outlined above, healthcare facilities can minimize the risk of electrical hazards and ensure the safety of patients, staff, and visitors. This includes selecting appropriate wiring methods, using hospital-grade receptacles, regularly inspecting and maintaining electrical systems, and providing training to building occupants. Remember to consult with qualified professionals such as electricians and building inspectors to ensure that all electrical work is performed in accordance with applicable codes and regulations. Prioritize safety in all electrical work and never attempt to perform tasks for which you are not qualified. By adhering to these principles, healthcare facilities can create a safe and reliable electrical environment for everyone.